It's Halloween and we're gonna show you the ghost penny. And I'm here with table 1, and all you need for this is a tray of ice water, a Coke bottle, and a penny. So table 1, flip that bottle over and cover the mouth of the bottle with a penny so it makes a wet seal. So the penny is wet and the bottle is wet. And Mahalit is gonna put her hands around the bottle, and we want to ask what makes the penny move. So I'm going to get really close. Oh, I just saw it move. It moved again. Oh my gosh. What do you think makes the penny move, Mahalit? Erica, you want to try it? Erica's going to try it. Okay, Erica. The ghost penny. What makes the penny move? Oh, it moved! It moved again! What's making the penny move? Because I don't see you moving it. I mean, you're not touching it with your fingers. Chase, do you know what makes it move?
The air inside.
Okay, there is air inside. What's the air doing inside there?
It's coming up.
It's coming up. Chase, prove it. You grab it. Let's see what happens. Just moved. So Chase, if the air is rising in the bottle and that penny is wet, then the only way the air can get out is by pushing the penny aside, right? Mm-hmm. So when you have hot air rising, what kind of heat transfer is that? Hot air. Is that convection or is that conduction?
Convection.
That's convection, yeah. Heat transfer through a gas is convection. Now, when you touch the bottle, your hand is solid, the bottle is solid. What kind of heat transfer is that? Solid to solid.
Conduction.
That's conduction. Good job, table 1. And I'm here with table 2, and you guys are ready to flip your bottle over to demonstrate the ghost penny. And take out that penny. Now, this is a tray of ice water. And we're going to cover the mouth of the bottle with a wet penny so it makes a seal. Okay, go ahead and grab the bottle with both hands. And let's see if the penny moves. All by itself. Oh, it did. Watch it carefully. Can you hear it? I can hear it clicking. Okay, what do you guys think makes the penny move?
The convection.
Yeah. Convection and air. Okay, so what makes the air warm inside the bottle?
Our hands, because it's a conduction.
Okay, your hands are conducting heat, right? Solid to solid. Okay, and as the bottle gets warm, then the air inside gets warm. Dorian, what does warm air want to do?
Go up.
It wants to go up. And when it tries to go up, it hits that penny, doesn't it?
Yes.
And then the penny has to move out of the way for the air to get by. There it went. Table 2 and the ghost penny. And I'm here with table 3 to demonstrate the ghost penny. And go ahead and flip your Coke bottle over. Take out your penny and cover the mouth of the bottle. And as you hold it, see if that penny moves. Ooh, I saw it move. Moved again. What makes the penny move?
Convection and air.
Yeah. So you've got a convection current there. Is the air warm or cold when it moves up?
Warm. Warm.
You're right, it's warm. What makes it warm?
The conduction from our hands.
Ooh, Kaden, the conduction from your hands. Your hand is solid and the bottle is solid. Persia's gonna try it. Or Greg's gonna try it with Persia. Let's see if it moves. You might have to get the penny wet again. So if you're doing this at home and it doesn't move right away, get it wet again and put it back in your ice bath. This is just an ice bath, just a tray of water with some ice cubes in. And then hold it when the penny completely covers the mouth. Try it right now. You'll get it to work. Okay, and now I'm coming to table 4. Table 4, take out your bottle. You guys are ready. That's right, Alacia. Now, I would put it on the table so it's not rocking back and forth because you want a good seal. That's good. Okay. All right, Gabby's going to try holding it. Let's see if that penny moves. Ooh, I saw it. There you go. Oh, theirs is moving really fast. What makes the penny move? Is it a ghost?
It's the air inside the bottle.
That's right, Alicia. There's air inside the bottle. And when you hold the bottle, does the air get warm or cold?
Warm.
Yeah, it starts to warm up. Oh, I'm seeing it move. That is cool. And when it gets warm, that air wants to convect upward, and it hits that penny, and it wants to move it aside. Good job, table 4. Okay. Table 5. I see you've got a bottle and some ice water. Go ahead and flip your bottle over. Take that penny out. And then, that's right, Alex. Cover the whole mouth of the bottle so no air can escape. Okay. Let's see if the penny moves.
Carla, you want to hold it too?
Oh, I saw it move. It's moving. Isn't that weird? Is it a ghost? Or is it science?
I want to say both.
Alex says both. All right, what makes the penny move?
Convection and heat.
So, so convection is when heat moves through a gas, right? And the air inside that bottle gets warm when the conductive heat of your hand touching the bottle transfers to the air inside. And now, what does warm air want to do, you two? What does it want to do?
Rise.
It wants to rise. How about you two try it? Give it a try. Ooh, I saw it move. Oh, I saw it move again. The ghost penny. There it moved again. Now, as it slows down, just simply put it upside down in your ice bath again, and then you're ready to go. Okay, I am to table 6. I haven't forgotten you. Flip your bottle over, table 6. Remember what the essential question is. What makes the penny move? Good. And you sealed the lid. Oh, let's see if it moves. Oh, I saw it move. There it goes again. Isn't that weird? So, what makes the penny move?
The conduction in our hands.
Yeah, so your hands are creating conductive heat because your hand is solid, the bottle's solid. What's inside the bottle that gets warm?
Hot. Cold air.
The cold air becomes
Hot.
hot air, and then what does the hot air want to do?
Move up.
It wants to move up. And as it moves up, it hits that penny. If the penny is wet, it creates a seal, and it wants to move it aside. Good job, table 6. Now to table 7. Table 7, take out the bottle. You're ready. There you go, and put a penny over the mouth of the bottle so it's sealed. That's right. Okay, now, let's see if that penny moves. Is it a ghost or is it science? Alden, you look really serious. Alden, what makes the penny move?
The cold air getting hotter and it's moving up.
That's right. Yes, the cold air is getting hotter and it's starting to move up. Now, can you guys tell me if your hands touch the bottle, is that conduction or convection? Your hand.
Conduction.
That's conduction because your hand is solid, the bottle's solid. So that heat transfers, it moves from the bottle to the air inside. And then what does hot air want to do?
Come up.
It wants to come up and it hits that penny and it says, move aside, penny. And it even kind of makes a clicking noise when it does move. Very cool. 6th graders learning the difference between convection and conduction with just an ice bath, a penny, and a pop bottle in RamZland.
Welcome to RamZland!
We're starting our unit on heat transfer, and I'm here with my assistant, Danon, and he's going to heat up this brass bearing. Now, Danon, before we heat it up, can that brass bearing pass through the loop? Go ahead and pass it through. It does. It passes through. We just want to make sure that we can see that. Now, when we're finished with this, we're going to cool it down in this beaker of water, and we're going to see what happens when it reaches room temperature again. But the first thing is we've got to turn on our heat. Okay. And Danon is going to start heating up that bearing. You're doing great, Dana. Keep it in there. You want it to get really, really hot. Okay. Now, Dana, I want you to see if it'll pass through the loop now. Actually, hang it. From this hand. Yeah, hang it from this hand. Like this. You can see that it's completely stuck. You can actually dangle it. Just let it dangle. So the first question is, the blowtorch. What kind of heat transfer came from the fire?
Radiation.
That was radiant heat, right? Now, when this hot bearing is touching that ring clamp, that's a solid to a solid. What kind of heat transfer is that?
Conduction.
That's conduction. Okay, now, it's stuck right now. Danon, I want you to put the bearing into the water and see what happens. Hold it in there. Keep it in there.
It looks big.
It's cooling, isn't it? Yeah. Okay, now, Danon, take it out and see if it'll pass through the hoop.
Yep.
Isn't that weird? Okay, so a couple questions, friends. Yeah, one question is, why did it get stuck? Why did it get stuck? And when he put it in the water, why was it able to pass through the ring? What do you guys think? Yeah. Go ahead. Brayden, why do you think it can pass through? Anybody have any ideas why it got stuck?
Because the heat made it.
Yeah, Diego Vey, I see you.
Because maybe since it's radiant, it's on conduction, maybe when it's heating up, it's...
Does the heat make the brass bearing larger or smaller?
It makes
It's still
larger
dangling.
because
Yeah, heat expands objects. So the longer you heat it, that brass bearing actually expands. You want to try it again?
Yeah.
Okay, so right now, it'll pass through. We're going to turn on our heat again. Let's try it again. So does that brass bearing get larger when it's really, really hot? It won't look larger, but it actually is. So here we go again. All right. We're getting it really hot, and right now that brass ball is expanding. It's getting larger. It doesn't really look like it is because it's very slight. This is thermal expansion. You're doing great, Damon. You're definitely in the right class. All right, now let's see if it's stuck. Hold it up. Now let it hang from that ring clamp. Let it hang. It's yep, just like that. That's exactly right. Isn't that bizarre? So it's larger. It's larger just from heating it. Okay, go ahead and put it in the water. Put it in the water. And now it's shrinking.
Ooh, that's hot.
Yep. Okay. Now try it. Thermal expansion in RamZland. Good job.